Welcome to chemistry. My name is Mr. Johnson. I'm one of the chemistry teachers at Chiawana, and this is the beginning of our introduction to chemistry and how chemistry affects our life and the world around us. So I'm going to go over the notes with you, and hopefully I'm going to underline things. I'm going to talk about important things as I'm going over these notes. If you'd like to make notes on your own paper or on the notes that you may have, you're welcome to. I will underline things, I'll highlight things. Again, I'll talk about things that are specifically important that I really want you to know. The cool thing about chemistry is everywhere around us. And chemistry is one of those sciences that really affects every single part of your everyday life. So some of the silly things that I came up with about what does chemistry do for us? Well, one of the things that chemistry does is it makes French fries taste better. The oil that they use in French fries makes the French fries taste good or makes them not taste good. Okay? One of the recent discoveries with chemistry is they've made glass that ice won't stick to. So think of a windshield in the morning in the winter that you have to go out and scrape. Well, in the future, you're not going to have to do that because they figured out a way so that ice won't stick to the windshield anymore. And those are kind of some silly things. But really, some of the important things that we deal with in chemistry are, think about medicines. Think about medicines that, for example, in a cure for cancer, if you went into the doctor and the doctor said, oh, you just need to take this pill, you have cancer, you'll be fine in a week. Gosh, that would be great. Okay? Or even think of COVID-19 or coronavirus, whatever you want to call it, a vaccine for that. How do you think that they're trying to find that? A cure for that or a vaccine for that all deals with chemistry. Or even some things that we use every day like gasoline. How can we use petroleum, which is that oil, black stuff we pull out of the ground? How can we use that to make the world clean, yet still stuff that we are able to use? So all of these things and so many more things involve chemistry. Okay? Well, what are some jobs and what in the world around us? What are some jobs that you might find in chemistry? One of them is what's called a chemical engineer. Okay, and chemical engineers solve problems that involve the production or use of chemicals, fuels, drugs, food, etc. There's tons of different types of chemical engineers. Okay, when you watch TV and you see those crime scene specialists, those are called forensic scientists, and they collect and analyze data from crime scenes and they try to figure out what happened and who did it and all that stuff. If you think about pharmacy, a pharmacist is someone who obviously works in a pharmacy that helps distribute prescription drugs to people. And honestly, then there's the whole medical field. And the medical field is so huge. There's so many different areas, from doctors and nurses and veterinarians and going down the chain kind of to medical assistants and LTMs and RNs. And there's so many things that involve chemistry if you're thinking of getting into the medical field. And again, that's just 3 or 4 examples there. That is certainly a very, very small sample, but chemistry, there's a ton of jobs out there that involve chemistry. And right now, this very day, this is the beginning of your chemistry journey. And hopefully it's not the end. This might be like, I'm done with the whole chemistry thing. I don't want to take any more. But maybe this just might spark some interest in you, and hopefully by the end of the year you might think, oh, that chemistry, that's kind of cool. And you never know. I've had some of my old students that have graduated and gone on to get degrees in some kind of in these kind of areas that have are very thankful for what they learned at the beginning of their chemistry journey. So let's talk a little bit about what chemistry is. Chemistry, as I said at the beginning, is the study of matter. Okay, what the heck is matter? Matter is all of the physical material of the universe. It's the stuff. Anything that's made of anything at all is made up of matter. And so a lot of times I like to, instead of talking about what is matter, let's use some examples, because then I feel like I understand it better that way. So some examples of matter. So these are examples here. Dirt is made up of matter. So is water. So is air. Even though you can't see something, doesn't mean it's not made up of matter. Okay, clouds, which are just little droplets of water, also matter. And every single element on the periodic table, from number 1 hydrogen till the very, very last one, all of those are made up of matter. Okay, what are some things that aren't made up of matter? It's pretty simple. Energy. Okay, energy, and there's lots of different types of energy. For example, sunlight is a type of energy. When you listen to the radio or you use your cell phone, that's using what's called electromagnetic radiation. Even heat, all of those are just different forms of energy, and energy is not matter. Okay, here's an example of some different types of matter that you'll find here. For example, is the Earth's crust. The Earth's crust, surprisingly, is made up, about half of the Earth's crust is made up of oxygen. Our human body is made up of about 65% oxygen. And then we've got some carbon, we've got some hydrogen, we've got some other elements in there as well, whereas the Earth's crust got some silicon, aluminum, iron, a little bit of calcium, and then some other elements in there as well. Okay, now some of the terms that we use with chemistry are what are called atoms, and atoms are what we refer to as the building block of all matter. So each element on the periodic table, which we'll talk about here in a little bit, the periodic table is made up of atoms of that element. So carbon, the element carbon, is made up of carbon atoms. The element zinc is made up of zinc atoms. Magnesium is made up of magnesium atoms, etc. Okay, sometimes when you put those elements together, if they're two or more non-metals, that's the key right here. Two or more non-metals put together, you get what's called a molecule. So you take two or more non-metal atoms and you put them together. For example, hydrogen is a non-metal, and so is oxygen. You put the two of those together, you formed a molecule. Okay, but they must be non-metals to be considered a molecule. Okay, so this is the oxygen molecule here. This is called ammonia. Ammonia is a molecule, and this is the chemical formula of propane. C3H8 is propane. Okay, a compound is two or more different elements. So notice it doesn't say whether it's two nonmetals or a metal with a nonmetal. It just says two or more elements that chemically react will form a compound. So a compound can be two or more nonmetals. So just like a molecule, but it could also be a metal plus a nonmetal. Okay, so NaCl is called sodium chloride. That is a compound. That's a sodium atom and a chlorine atom put together. Here is water again, just like it was with molecules. This here is called calcium phosphate. And again, you don't need to remember that, but this is calcium, this is called phosphate, this is called potassium nitrate. All of those are compounds. Anytime you put two or more elements together, you've got a compound. Okay, so here we can see kind of some different drawings of that. Atoms, they're just kind of by themselves. Molecules, again, must be non-metals. And so this, for example, could be O2, because you can see there's two atoms put together. Here are what could be the molecules of a compound, and here's a mixture of all three of them. Okay, now some real life compounds, and again, remember, a molecule can also be a compound. Okay, a molecule is just a little bit more specific that it has to be nonmetals. Okay, so here we can see here's the oxygen molecule right here. Here's the water molecule. This is H2O. Carbon dioxide is CO2. That's a carbon atom here in the middle, and that's an oxygen, and that is an oxygen. So when we breathe, that's what comes out of our lungs. Ethanol, you know, when you get gasoline, you go fill up your tank, it says may contain up to 10% ethanol. So ethanol is C2H5OH. And so you can see that, again, the black ones in there are the carbons. Then you've got these gray ones, those are hydrogens. And then you've got that one oxygen right there. Okay, ethanol is also a type of alcohol. It's what they use in alcoholic beverages as well. Okay, ethylene glycol is this bottom one here. Ethylene glycol is more commonly known as antifreeze. And aspirin, a very, very large molecule with this cool little ring right here. Aspirin, also just a different type of compound that you will see. Okay, now most of the states of matter that we will see in this class will either be, sometimes it'll be in a solid form, and the abbreviation for that is just an S in parentheses. Notice it's kind of italicized. And then you've got a liquid state with a lowercase l, and then you've got gases. Okay, there's one more that we will talk about as well here in just a minute. Okay, but solids generally, again, not always. Well, what about a sponge? People always want to have some examples of when it's not this way. But solids generally do have a definite shape and a volume. Okay, the atoms are really, really close together, and they're held tightly, so they can't really separate from each other without adding some energy to them. So they can vibrate or wiggle a little bit, but they are very, very close together and don't generally come apart unless, again, there's some energy added to them. Okay, liquids, on the other hand, also do have a definite volume, okay, but they obviously don't have a specific shape. You pour some water into a pitcher, the liquid takes the shape of the pitcher, okay? The atoms, like a solid, are also very closely packed together, but again, the attraction between the atoms is not as strong, because in a solid they're stuck together, where in a liquid they can kind of move around each other. Like when you pour something, that's the atoms are sliding over each other, okay? And when you pour something in a liquid state, that is what happens, is the atoms are kind of sliding all over each other. Okay, and then our final one out of these three is what are called gases. And gases, different from solids and liquids, have no fixed volume and no fixed shape. Okay, which means you've got one gas here, you've got another gas here, and they are independent of each other, and they do move really, really fast, and they collide with the other gases very, very frequently. Okay, and obviously you take a gas and you cool it down enough, that's called condensation, and certainly it will turn back into a liquid. Okay, another one that we will see later this year that really isn't a state of matter, but you will see it kind of like this, where with a letter in, or letters in parentheses, is something that's called aqueous, A-Q-U-E-O-U-S, and you abbreviate that by writing AQ. Okay, and what is that? Well, it's kind of a mixture of this and this, of a solid and a liquid. It's when you take like some salt and you put it into water. What happens to the salt? Well, certainly it dissolves. Okay, so when you dissolve a solid in water, you get an aqueous, what's called a solution. Okay, so you take some salt, you put it into water, you take some sugar, you put it into water, you take anything and you dissolve it. Okay, what you formed is what's called an aqueous solution. So it's not really a solid anymore. It was a solid, but it's not really a liquid because it's dissolved in the water. The water is the liquid. So what is the salt? You could say the salt is an aqueous solution. Okay, and that is it for Unit 1.1.